Good morning, everybody. We are dealing with technical things, like I have heard a lot of noises, and it's either the internet or it's our computers. So you have already figured out by now that having two speakers and two microphones on at the same time creates problems. So we are trying to work off one microphone and have only one speaker on, and that works usually. I hope you all can hear me. Can you all hear me?
Yeah.
There we go. So good morning and welcome to the STEM Seals Summer Institute. My name is Dr. Günther Maresch. My last name is unusual. It's Maresch with the A pronounced like in the word father, and the accent is on the first syllable, Maresch. And I was born in Germany, and my native language is German. So if you don't understand, I do the best I can to use English. I teach physics, astronomy, and mathematics at North Florida College. And that brings me to the STEM Seals. The STEM Seals project is a research project of the National Science Foundation. We are fortunate that the government in Washington runs that agency, which funds about a quarter of all research done in the United States, and one department is a department of K through 12 education, and we, the STEM Seals, are part of that program. So first, I want to get started with what STEM Seals are. And if you Google STEM Seals, you get automotive parts, because a STEM is actually a word which is part of the valves in car engines. And if they have to be sealed because otherwise the oil would leak, then you find STEM Seals on the internet. Of course, you all know that STEM actually for us means science, technology, engineering, and mathematics. And the word seals is based on, we didn't invent that. It's based on the Navy SEALs, the Special Operations Command of the United States Forces. There are SEALs because the SEALs operate anywhere meaning at sea, in the air, and on land. And this is why we are the STEM Seals. The STEM Seals project originally was designed and still is designed as a land, air, and sea project. And maybe I can show you all a little bit closer what I'm talking about. I just take the camera. Here is the Sea Challenge, or the devices of the Sea Challenge. These are boats which go in the lake. And then for the Air Challenge, here are a few of the drones which students in the Air Challenge will learn why they fly, how they fly, and to fly them and actually compete by flying them. However, then the COVID virus got us really bad. And this is why you all this year are all in the Rover Challenge. So we are actually doing this week and next week only the Rover Challenge. But if you have fun this summer, then we definitely plan to have the other challenges as well next year. So there are the STEM Seals. We, the people here at North Florida College and our partners in North Carolina, we consider ourselves as the expert team of the STEM Seals. But all of you teachers and students, I consider you also as STEM SEALs, because the Navy SEALs were actually teams of special forces. And Again, I would love to have you here and no COVID virus anywhere in the world. Then we actually could work together and could make teams of students. Well, we have changed this slightly. You are teams with your teacher, you are teams with your parent, or you are teams with your grandparents. So the STEM SEALs are our team, your team, and actually the whole project together. We are one big team because what we're really doing is not assemble rovers. And yes, we're doing assembly of rovers as well, and we program them and we drive them around. But what we are really trying to do is figuring out how to improve our learning experience at school or out of school. So at the very end of the project, when this is over after next week, and during this time, you will be asked many questions and you will be thinking about a lot of things. And the project really relies on your input, on your feedback, what you find well, what works well, or what you find what doesn't work well, what doesn't work at all, or what you would like to feel should be done differently. You also have the freedom. You will keep, each one of you will keep the rover and all the parts. And after this is over, you may want to make something completely different out of these different parts. And we encourage you to do so. Those parts can do amazing things. And you will find out, you will learn how to do these amazing things. So help us with your feedback. Whatever you're saying, don't take these questions as this is not a class with a final exam. This is more like, tell us what you think and tell us what you find out. Tell us what you think is strange and tell us what makes perfect sense to you. At this point, I would like to simply introduce the team. I take the camera again and just show the way around. We are in my physics classroom, and oops, we are not a camera team, so I cannot do. Here's Laura, here's Chris, and here is, go closer, here is Bill. I would like each one of us of the expert team to introduce ourselves. And I mentioned earlier very, very briefly that part of us is in North Carolina, and I would like to ask Adrian, can you just say a few words, who you are and what you do?
Sure. Hello, everybody. It's really great to be able to join you from North Carolina. I am really excited to learn about your experience in STEM SEALs and to study your experience. And I'm just excited to be a part of this.
Thank you, Adrian. And Chris, let me unmute my microphone. No, mute my microphone.
Hi, I'm Dr. Chris Paco. I'm here as part of one of the members of the STEM SEALs program, and I look forward to working with each and every one of you, especially on Friday this week with the remote part of your programming, and also on next Wednesday, which is actually an open day for us. So if you have any questions at all, any concerns, please feel free to contact me. Again, I look forward to working with each and every one of you.
All right. Thank you, Chris. And
hi all, how are you? I'm Laura Sapp. I'm the project coordinator here at STEM SEALs in North Florida College. I am so excited to be part of this project. The cool thing is that I've worked with some of the teachers on this program. Actually, I've been in the schools and met all of the teachers. So those student participants, I've worked with either your parent or your teacher, and we had a blast learning a little bit about the microbit. And some of you, I've actually even had the pleasure of teaching before in class. So this is great for me to get to be part of a project that brings things back to the North Florida classes where I've been a part of, to be able to give you STEM tools that you can use and learn from. To me, that's the exciting part of this grant. I'm so glad that I get to be a part of it. So we're so glad you're all here. Thank you for coming. If you have any questions, I am available. Just please get with us. Don't get stuck on something, and we're here to support you all day long. All right. Talk to you later.
Thank you, Laura. And Bill, would you?
We can't hear you, Bill.
Can anyone else not hear anything?
I think they're fixed now.
You're good?
Good morning.
we're
My
good.
name is Bill Eustace. Some of you I know. I've seen you for our design team. Some of you I don't know. First time meeting you. I run a program here at North Florida College called Advanced Manufacturing and Production Technology. You'll see on your rovers many of the components, the black plastic pieces, the Lexan, those were laser cut in my lab. The small component that runs the servo motor at the front, it is red on some, blue, gray. It was dependent on the material that I had that I could use to print with. But a lot of the components that are on the rover were fabricated in my lab. I look forward to working with everybody. I'll be with you on Thursday for the assembly section. Please feel free to reach out to me, and we'll do the best that we possibly can. I want you to have fun, learn, and as Dr. Marish indicated, please give us your feedback. Any questions that you have, things that you see, whatever you want. This is your camp. All right. Thank you. Good meeting you.
Thank you, Bill.
Question. Are both the bags one rover? Or are they two different rovers?
I believe it's one rover. They may be answering your question in just a moment. Looks like they're pulling
Okay,
up a new screen.
it's good.
I'm also going to mention that there is a chat feature in Zoom. So besides just asking your questions here, which is great, you can also use the chat feature, and I'll try to look at that to make sure that nobody's questions get missed.
Okay, let me make a little detour. I want to talk about what are we doing? What do we expect to do? And I want to start with this little guy. And can you all hear me? I'm not sure. Okay, not good. What is a robot? And when I think about what a robot is, well, not all robots look like this. But let me figure out how to do this. Well, doesn't work. It has legs, it moves like we walk. A robot could walk. Well, our rover will not be that advanced. It's more complicated to make it move walking. It will have wheels. It has eyes to see, and eyes is only one of our sensoric organs where we detect what is around us, and a robot may have sensors. It has batteries, it needs energy, and well, how do we get energy? I hope you had breakfast this morning. And that gives you energy to work during the day. And if you forget to eat, you get weak and you will get hungry and you will get more energy. Rovers and robots usually don't eat. We will be using batteries, and most devices have batteries as energy storage. But nothing would work if there wouldn't be a brain. We wouldn't be able to move. A rover wouldn't be able to move without controls of the motors, controls of the sensors, detecting the data coming from the sensors, processing those data, and therefore, well, our control center is our brain, and robots have computers. And what you already have is a microcomputer, a very small computer, and it will act, or actually you will make it work as the brain of the rover. So you see, I make connections between the machines and human beings, or actually animals have eyes too and have legs too. What's the difference between a robot and a human? And I only will leave that question right now because next week, later next week, we will be talking about that again, and we can talk. If we work really, really hard, we can make very, very intelligent machines, like your cell phone is a very intelligent machine. It can do amazing things, but it's still not a human being. And eventually, at least I hope we get some chance to talk about artificial intelligence. Artificial intelligence where devices, human-made devices like computers and robots, show actually intelligent behavior, and we all together, we will actually try to make our rover an intelligent machine. So here is how it looks like, and here you see the same words. The wheels are for motion, the computer is the controlling brain. The sensor will be an ultrasonic sensor in the front, which looks like eyes, and you will find out, well, it doesn't work as well as your eyes. And there are some batteries without which it wouldn't work at all. There is actually a much more advanced rover, and I really want to play that video if I can. Nothing is in the right place. Oh, it actually works. Okay, this is the rover Curiosity on Mars. It's currently, and it already has been for years, on Mars. You see, it is a very, very complex machine. It's actually a very expensive machine. None of us could afford to make a machine like this. But I mention it here because, yes, you and we here will be making toy-like rovers. It will be like a little game. You will be putting the wheels on, and you will be writing code to make that toy move. But if you want to think about, well, is this just another play or another game to do? Well, then I have to say, this stuff actually is really, really serious. Because our rover, and let me just go back here, the rover we make, at least in my mind, each one of these parts reflects a job you may get after you made it through school, after you made it through college, and you get a profession, you want to do something. And now have a look at this picture again. There are wheels which turn, and of course the wheels turn because there are motors. Making the motors takes engineers, mechanical engineers and electrical engineers, and actually there is some technology about materials in there as well. So making these is not just going outside and finding a few pieces and putting them together. I think you all realize that making a motor is probably not so easy to do. Or if we look at the computer and the motor driver board, these are electronic components. So there are jobs behind that. Of course, again, mechanical engineering, but certainly electrical engineering, electrical design, and there is actually some chemical engineering in there as well. In particularly when we look at the batteries. Batteries is chemistry which produces power, and well, chemical engineering or a chemist, this could be a job you have in 10 or 20 years working on improving or making larger batteries. Even the simple plastic devices. There is manufacturing in there, we have drilled holes, or actually Bill has been doing advanced manufacturing by laser cutting or by 3D printing those pieces. And again, there is mechanical engineering in the machines, there is electrical engineering. Actually, these machines are also intelligent machines which produce those parts. So there is also computer science and coding in there. So again, now I hope you have another view of this rover, which reflects actually many different kinds of jobs. And not everybody can do the same thing, but of course you go to school to learn a little bit about this, a little bit about something else, and that will eventually help you to find out what you really want to do, what you really find cool, and what you would like to work on and make it better than anybody else can do. So my next piece is, where do the parts come from of the rover you have? You have a package, and this is the content of your package, and I can guide you around. Well, here we go. The chassis with the motors and the wheels and some bolts, they come from China, including the ultrasonic sensor. And then the electronic components, the microbit, our microcomputer, and the motor driver board, they actually come from Great Britain. The tools are made in Germany, and the plastic parts are manufactured right here in Madison County, right here at North Florida College in the Advanced Manufacturing Center. So here we go. These are the plastic parts which hold things together, and okay, I'm getting better with this. The servo motor mount parts, the parts in the upper left, they are actually 3D printed devices. They actually grow while you watch. While the other parts, they are laser cut, which simply means it is a flat sheet and the laser cuts out the shapes in very fast motion, and then we bend them to shape, and this makes the part of the rover. I made this detour to say the rover, which is in your package, actually partially comes from all over the world. It was collected here and it was put together in this kit with the purpose that we can combine in an efficient way that brain, those wheels, the sensor, and the computer, that eventually in a couple of days you will have a functioning rover. So in the middle of all this, all these parts come from all over the world. In the middle of this, there is you. You have them right in front of your in front of you on the table, and you will assemble the rover to a functioning piece. So here's the plan. Today's Wednesday. And first, we look at the brain. We need to understand how to make the brain work. So that's the main task of today, and we call this Module 2. Tomorrow, we will spend some time to assemble the rover. It takes an hour or two, and if there are problems, a little longer. But at the end of tomorrow, you will have the rover in the shape I just showed in the little slide before that. And on Friday, we make it move. We make it move and turn and test it out if it actually works. And here is part of the engineering you will experience. Some of your parts will work and some of your parts won't. This is the normal engineering process. You put something together, you test it out, and some works and some doesn't. Maybe some of you are lucky and everything works, but I think this is the exception. And that's normal, because an engineer puts something together and tests it and examines it, what's missing, what did go wrong, even what broke, and figures out what needs to be changed, what needs to be repaired, and we're going to do that. And we have enough time between our tasks we are going to perform that I am pretty certain, our team is pretty certain that each one of you, you will be successful. Don't get frustrated. Believe me, it's normal that things go wrong and don't work. Don't get frustrated. Remember, the E in STEM is engineering, which simply means let it go wrong and simply ask yourself the questions, how can I figure out what is wrong? What did go wrong? What can I do? And we, the experts, are actually here to help you and to be on your side, and I'm confident you will be successful and it will work. Now, next week, things will become more complicated. Now, next week on Monday, we will be activating the sensors of the rover, which will allow, which will the rover allow, well, which will you allow using coding on the computer on the rover to find out if there is something in the way or not, and how far it is. And then we will get there where we say, oh, maybe we can make our rover more intelligent. Meaning, of course, you recognize the obstacle because you look at the obstacle, but can you make the rover do something else? Can you make the rover deal with the obstacle? That's the goal of Monday and maybe Tuesday and maybe Wednesday. So Tuesday and Wednesday are pretty open days for testing, improvement, and practice, because on Thursday and Friday, each one of you actually will perform a couple of competition tasks, and we will compare who can deal with the challenges in the competition the best. And for that, it's really, really important that you use the time on Tuesday and Wednesday for test and improvement. And actually, there is some flexibility. You will see, and I believe, the instructions are very concise. If you pay attention to the instructions, you will achieve certain tasks. However, the instructions towards the end leave you freedom. They leave you freedom to choose parameters or to change the code or to change things around in a way where you think it could work better. And this is exactly what the engineer does. The engineer tries it this way and tries it that way and assesses if one test is coming out with better results or worse results. And in those 2 days, you have to make a choice. What do you think is the best your rover can perform? This is what you will be using for Thursday and Friday. Although all your rovers may look the same, and believe it, we have assembled quite a few, they can operate quite differently. that in mind and do the best you can. Now, all this sounds very, very serious, and I forgot the most important thing to say. Certainly, you also should have fun figuring things out and making it work. So we are here to help you. And for us to get our feedback, remember that it is a research program. I would like to ask Dr. Smith to add what you would expect in addition to those mechanical tasks. What you need to expect to be in between those tasks to make the research work as well. Adrian, can you take over?
I can. Did you want to stop sharing your screen? It might make it easier for students then to be able to have a face with the voice. Great. Are you all able to see me now? Are you seeing me? Great. Yeah. Great. Excellent.
Yes.
So I want to give you, thank you. I want to give you guys just a little bit more information. Again, my name is Dr. Adrian Smith, and my colleague, Dr. Rebecca Zulilo, will be joining me as well. We are education researchers from North Carolina, and by education researcher, I mean we basically study the effectiveness of different interventions and programs like STEM Seals. So the goal of STEM Seals is to see if students like you can experience a program like STEM Seals and become more engaged in STEM, learn more about STEM, like how to think like an engineer or a scientist, and whether or not this kind of experience makes you consider a possible career in STEM. And not only do we want to see whether or not those goals are met by your experience with STEM Seals, but we also want to understand how STEM Seals and those materials can be made better in order for those goals to be reached. So to do that, we're going to need, as part of the research, a couple of things from you. One is we're going to need you to take kind of a lot of surveys in the beginning here before you get ready and ramped up to dive into your rover. And some of the questions might be kind of hard because they're really things that you probably don't know yet. But what's going to be really exciting is that you're probably going to know the answers to a lot more of those questions when you finish building your rover and do the competition. So you'll be asked some questions in the beginning here, and you're going to be asked to answer some surveys at the end. And that goes for educators too. We have some questions for you in the beginning and the end. And we also are really relying on you to help us improve these materials and improve this experience for students. So you'll be asked some questions too throughout, as well as the students for the students, it's more to just kind of get a sense of what you're understanding in each of the modules. And for educators, it's to get a better sense of what you think the students were able to do easily, what kind of gave them difficulties, and suggestions that you have for how the materials can be improved. So the next thing that I want to do is to be able to read a little something about the experience of being in a research study. And I know that your parents and educators, you have had consent forms and permission forms to participate in this study. But as students, I'm also going to need you guys to say that you are willing to participate. So I'm going to read a little something here, and at the end, I'm going to ask if you have any questions, and then I'm going to ask you if you are willing to participate. So you are being asked to be in a research study about engaging students in engineering. A research study is just a way to learn more about an intervention and its effects. If you decide that you want to be a part of this study, you will be asked questions and asked to share about your experiences as you work through those STEM Seal online modules with the support of a designated educator and the North Florida College instructors and staff. And this is going to take you, as Dr. Marish just went over, about a week and a half. So here's some things you need to know. The researchers will review your responses to the questions and any information that you provide as part of your online experience. During each module, you're going to be asked to answer some questions online and share about your experiences. This study is going to take place virtually, and not everyone who takes part in this study will benefit. A benefit means that something good happens to you, but we think these benefits will be of greater interest in science and engineering. We will minimize the risk to your privacy by being sure that only authorized staff involved in the study will have access to the study information. The Institutional Review Board, which is called Integ Review, and accrediting agencies, these are groups that make sure that everybody's treated fairly in a research study. So these groups might inspect and copy your records, which could have your name on them. So absolute confidentiality can't be guaranteed. And if you do not want to be in this research study, you don't have to participate. When we finish with this study, we're going to write a report about what was learned. This report will not include your name or that you were in the study. That will be kept confidential. You don't have to be in the study if you don't want to be. You can say no and no one will be mad at you. And if you decide to stop after we begin, that's okay too. So I'm going to stop for a second and see if there are any questions. All right, if there's any questions that happen at any time, you can reach out to me or any of the members of the team that have talked today. I'm also available on the chat here, so if a question comes up, you can respond there. But at this time, if you are a student, you're willing to be a part of the STEM Seals experience, can you just unmute yourself and say that, that you agree?
I agree.
I agree.
Excellent, thank you all.
I agree.
You're also going to be asked to sign a piece of paper. It might be electronically to again say that you agree to be a part of the study. And at any time, if you do not want to be, you just say so and there's no problem. Thank you all. I'm excited that you're going to participate.
Thank you, Adrian. And after this, we need some guidance to get into this, and I will turn over to Laura Sapp.
Hi, all. Okay. Hang on. Okay, so that's a little better. So most of you teachers know me, and some of you students, you'll all get to know me hopefully by the end. I wear many hats here as the project coordinator, so I'm going to go over some details that we all need this morning, try to keep it quick. First of all are those office procedures, so I have to take care of that. If I don't have your consent forms, teachers, when your student is possibly doing that one assessment that's going to take them a little longer and you're not involved in, maybe try to help me get these forms. If you are not sure, I may just send out a blanket email with them all attached, but if you're not sure, just send me an email reply to that and ask me if I have yours. Some of you, I think, actually typed on it and said this is your signature. If you can, to put a real signature on there, there's a free app called Adobe Fill and Sign that you can put on your phone, either an Android or an iOS phone. And it's really easy to use. So go to your app store. It's free. And what it'll allow you to do is if you actually have the document, you can take a picture of it, or you can upload it from the file. And then you can sign your name right on your phone if you have a smartphone, and it will place it on that document. And then you can just send the document back to me. I know that I have an app like that on my computer, and some of you do, but I think some of you are having issues with that. So if I'm still looking for forms for you and you can't get those, let me know and I'll try to help you. We do have to have those because of it being a research study. So that's the first office procedure I have. If you have any login issues, obviously, or tech issues, and obviously you can't get on the computer, you guys have my email, but if your internet goes down, I'm going to post on the stream in a minute my cell phone. Just send me a message, but make sure when you send me a text message, you tell me who's sending it to me, because I don't have all your numbers in my phone. But I'm going to go ahead and do that, because if you have a tech issue, we won't know. And I'm not in my office today. Obviously, I'm in the science lab room. And so if I forward my office phone, by the time it comes to my cell phone, you usually have already hung up. So I'm just going to give you all my cell phone. Please do not hesitate to use it. Send me a text. Even if you're working over the weekend, we're going to be available by email and phone. Send me a text and I'll make sure you get the help you need. We want to make sure that this is a very easy process for you. Zoom. This open Zoom will be open, or this Zoom will be open all day long. One of us will be manning this Zoom all day. I don't recommend you leave your camera on all day, because there's no telling who might walk in front of your camera. But if you have a question, all you have to do is go back to the stream. I've now posted that link in the stream. I'll repost that link every day so that you always have it handy. Go to the link, click on, and we'll notice you're in our Zoom room, and we will answer your questions. And I will be here. I'm sure some of you are going to have questions right off today, trying to get on and going. Again, remember to turn your camera off. Remember to mute when you're not talking, because you probably don't want us all hearing your private conversations. So those are some things just to remember. If you're filming a video for Flipgrid, make sure that you're aware of what's in your camera as well, so that we're not videoing things we probably shouldn't. We know we're going to have visitors in our videos, such as non-participants, kids that belong to our teacher friends that are not participants. They're going to wander in. We have a couple of animal friends when we work from home that always join us. So we expect that to happen when you're talking. Those are just normal things that happen. So, but if you don't want something in the film, be sure to turn your camera off or your microphone. And that's at the bottom of your screen. You'll see some different things. That's where the chat is also. Any questions on that? Okay, so now we're going to move on. Today, Dr. and I always say it wrong. You'll have to forgive me. Marish, did I say that right?
You're okay.
Marish, I want to make sure he's so good about that. Mentioned module 2 and the microbit. You're going to learn about the microbit, which is the brain of our rover. And that's what I came and taught your teacher friends that are going to be your mentors today. But before you get there, you need to do module 1. And that's those assessments that Adrian Smith, our researcher, was talking about. I'm going to go ahead and tell you, it's going to take you about an hour to do all 3. Let's get that kicked out first thing this morning. And I will start opening up module 2 as I see you do that. I'm going to share my screen for just a moment, because I shared this with your teachers in the orientation I did for them. But I want to make sure that you as the students understand when you get in the Google Classroom. So I'm just going to talk about a couple of things. First of all, the stream, once you get logged in, and you'll have to have your own Google account. So if your parent has not set you up one, you're going to have one. Here's where you're going to find announcements. Again, I just told you this is where you're going to find that Zoom link. So if you need me during the day or any of our staff, just click here and join our Zoom meeting. And then I just put a little welcome here. But look at this stream during the day. If we need to make an announcement to you, we will make it here in the stream to you. Classwork is where you're going to find all the stuff you need to do. And when you're working through these modules, you want to do it in order. So today you need to start with module 1 and scroll down, and there's a couple of assignments in module 1, how to use Google Classroom. If you already know, then you're good. Notice I'm actually in my teacher screen. I'm going to go to my student screen in just a minute, but I can see how many have turned this in already. Now there's really nothing to turn in. It's a video, but we just want to make sure if we have a video that's really important that you watch it. Some of this stuff isn't important, and it will say if applicable or if you need. This is mainly for your teachers down here. And if you don't have an iPad, you don't need to watch this. So when you are a student and you're going through here, here's what it's going to look like. This is me as a student. Anything that you still need to do will have a color right here. Anything you've already turned in will turn gray. So then you know, I got to go back up and look at this welcome to STEM Seals. There's just a couple of videos just to tell you what we do here as a team. It has that PowerPoint that we've already shared with you, so you've actually already seen that. But once you get to an assignment, you want to either click it up here or click down here where it says View Assignment, and it takes you to a one-page snapshot of that assignment. And here's what's really important. Right here on this screen, once you've done everything, and sometimes it's just watch videos. Once you've watched those videos, we want you to mark it as done, okay? And that lets us know we're not being the big bad teacher that's saying, oh, get your work done. We just want to know where you're at so that we can gauge the schedule and make sure that if we need to make adjustments, we can do that. So when you finish something, even if it's watch a video, and you don't do it for every video in a lesson, in this particular lesson, there's 6 things. You just mark it done when you've done all the things that are listed there. You will see when there's certain things we want you to turn in, but those are tests that we do once we get our rover moving. So for the most part, it's just kind of doing the activities with the rover and saying, hey, I did that. Now, sometimes we'll have Flipgrid videos that we will want you to do, and you're going to learn about Flipgrid right here. I've talked to your teacher mentors and they know a little bit about Flipgrid already. So these are the assignments. Let me go ahead and click this because it didn't upgrade. Okay. So you have those assessments. If you'll go ahead and do those today and then move into Module 2. So any questions on Module 1? Module 1 is just learning how to use Google Classroom, Flipgrid, and taking those assessments. All right, and some of you have already done that. So let's look at Module 2. Module 2 is the fun part that you get to do today. We're going to start, I apologize, there we go. Okay, so Module 2 is about learning about the microbit, which we talked about is the brain of the rover. So the first thing is a student guide, which really just tells you everything you're going to be doing. There are live links there, but you don't need to click all those links because the same thing that is in that student guide is also in each one of these. And it looks like a lot, but some of them, like this little assignment, is 3 little videos and they're no longer than 5 minutes for all 3 videos. So that assignment's only going to take you about 5 minutes, maybe 7 to navigate between. To watch the video, you're just going to click on it and the video will come up on your screen and you watch it. Once you get done watching it, again, remember you go here, you can click on that. Oh, I'm as a teacher, so it's not going to do it. But when you're a student, click on View Assignment and click that you're done watching it. All right, so the only other thing, I want you just to go through these microbit lessons. Your teachers have already been through these lessons because I came to the schools and did them with it. But one of the tricky parts of Module 2 that you're going to learn about is, I'm going to put, you have to look at my camera. So I'm going to quit sharing my screen so you can kind of focus on me. Okay. So one of the tricky parts of the coding, I mean, the coding is a little tricky, but it's how to save that coding. It automatically saves in the browser on your computer. But if you were using the same computer, with either another participant or your parent teacher, all of your projects are going to save on that home page. So we have provided, and it may be in with your rover parts. Do we pack that in the bags for most of them? Yes. Okay, so we would tell you not to open that rover bag till you get ready for assembly, but you're going to need to open it today. In your rover bag is a little white box, and inside that box is a USB drive that has North Florida College and the STEM Seals logos on it. And in Module 2, when you do those activities, even though it's going to save on your computer, we want you to get in the habit of saving it on this flash drive. And that way, if you're using your teacher's computer or a computer that's not yours, when you finish this program, you will have everything saved on your USB. So if you don't know how to use a USB, that's what your teacher's for, to help walk you through that. But if you get stuck, because this was, I'm going to tell you participants, this was tricky for teachers when we were there, because it will download on your computer as well, but it goes into folders called download and it's hard to find. So When you get to this part today and it tells you to save it, if you get stuck, instead of me doing a tutorial for everybody, when you get stuck, just if you can't figure it out, you jump in the Zoom and I will walk you through how to download it. I'll let you share your screen because it's different. It looks different if you're on an iPad or if you're on an Apple computer compared to a regular computer. And sometimes it's how you have your computer set for your downloads. Sometimes your downloads are alphabetical. Sometimes they are by the date. So it kind of works different for everybody. So if you get stuck and your teacher can't figure out how to download it, and teachers, you have one too, save all your projects. Here's the important part. When you get to module 3, when you start programming the rover and you do all this code work and you've done all this work, eventually you're going to build on that code. And instead of having to rewrite all the code every time, you upload from your USB into the make code. And I know this is all foreign to you because you guys haven't even learned about make code yet. And that's why I didn't want to do a tutorial before we got into that. So when you get there, if you get stuck today, please catch us on Zoom. We're here all day. And we will see you today because my little face is going to be sitting in front of this computer all day. So we will make sure that you get the help you need. Any questions, get with me. Teachers, get with me as far as your papers that you or your student still needs. I'm going to say another thing. Flipgrid, in the beginning, module 1, we teach you about Flipgrid and we ask you to go in and create an introduction. Actually, I'm going to click on that so you can see what it actually looks like. I have to go in as a student. Hold on a second. Oh, I've got to share my screen with you again. So I'm going to share my screen. So Flipgrid is a video resource that we can share videos. And when we put a link in there, all you have to do is click on it. Your teacher received your individual ID. You put in your ID and it takes you there. And so in module 1, you're supposed to introduce yourself to the other participants. We want to build a community. We want you to connect with other people that are in the 6-county area, that are students that are into rovers just like you, or into STEM stuff just like you. We want you to have that classroom feel. So when you go here, if you scroll down, look, we already have 5 videos posted. You can click on these videos, you can meet the teachers and the students that are going to be in this program with you, and you need to record your own by touching this plus symbol. So you can add your own videos. So that is the introduction in module 1. And Amanda, you added yours here because I didn't have it, and it's okay. I will see if I can't move it, but if not, we won't worry about moving yours. In module 2, when you get your microbit, and you may not have even, you shouldn't have unpacked this, but if you have, good for you, it means you're curious. When you get your microbit, you're going to code your name on the microbit. It's going to ask you to go to Flipgrid again and share again. I'll do it up here. It's going to ask you to share your name badge. So you're going to actually do 2 introductions, but this one, when you share your name badge later today and how you're feeling about STEM skills and coding, you're going to do another short video. Okay, so there's 2 kind of introductions and they're in 2 different places. One is going to just be called Flipgrid orientation introductions, and the second one, which I added, if you go to topics, will say name badge introductions, and it'll have a picture of the microbit. So just to clarify that. And that's all I have for you guys. Are there any questions? Okay, so get into module 1, get through that grueling assessment part, and get ready to have some fun in module 2, where you'll learn all about the microbit. And I promise you, you guys are going to have fun. And if you don't, you can come back and blame me. But I know you're going to have some fun. Anything else from anybody else on the STEM skills? Any questions?
I had one thing real
Okay,
quick.
Adrian, I'm going to mute so that.
Thank you.
Yes, go ahead, Adrian.
Thank you, Laura. I just wanted to let everybody have a moment to meet Dr. Rebecca Zulilo. She has joined us and she is also going to be talking and communicating with you to learn a little bit more about your STEM Seals experience. Rebecca, do you want to say a quick hello?
I do. Hi, everybody. I'm really excited to be able to learn with you this summer and look forward to being a part of this experience. So good luck to all, and I hope to catch up with you again soon.
Thanks, Rebecca. That's all from the North Carolina STEM Seals team. Do you have anything else, Laura, or the rest of the group?
Yeah, we got to turn sound down. Okay. I don't think we have anything else. If you guys have any questions, again, just stay on Zoom and we'll be here for you. And as you have questions throughout the day, please don't hesitate. I've opened all of Module 1 up for everybody now with your assessments. And as you start working through Module 1, I will begin opening Module 2 for you. As I mentioned to the teachers, if you have a really motivated student and I see that you've worked through all of Module 2, I will go ahead and open Module 3 up for those that I see have checked I'm done. That's why you need to make sure you check I'm done. So once, if you're motivated and you want to keep moving ahead, keep doing that. Oh, let me go ahead and mention, tomorrow, 9 o'clock, our whole STEM Seals team will be on again just for our 9 o'clock briefing every morning from Mission Control, just to kind of let you know what's coming up for the day. We hope you can all make it. We know sometimes scheduling prevents it. All our morning meetings will be recorded and put in the stream. So we'll have this one recorded and put on the stream here in a minute. All right. Well, thank you. I'm so glad you all are here and we're so excited to have you. Have fun.
See you soon.
Bye. Bye.
Thank you. Bye.
Bye, everybody. See ya. Bye.
Thank you.
Where's the
Laura, you were
leave
going to put your
button on
cell
the
phone
phone?
up?
Where's the leave button on the phone? Oh, I see it. Bye. See ya.
Yeah. Hey, Carter, hold on. Did you have a question? Okay. He's gone. I wonder if we should turn Mission Control off now and just use our computers.
Laura? Miss
Yeah.
Sapp?
Okay. But then I can't hear anybody speak unless I can turn my speaker on now. Okay.
Miss Sapp?
Yes.
It's Mr. Metzger. You were going to put your cell phone number up?
Yes. Thank you. I will do that right now. Thank you for reminding me.